Another means by which nitrogen can be lost from soils is through a process called denitrification. Now, denitrification is simply the conversion of nitrate or nitrite to nitrogen gases. So here are some examples on this slide. This is simply the biological reduction of nitrate. So reducing nitrate from nitrate to a gaseous form. This occurs under anaerobic conditions. So the soil must be saturated for at roughly about 5 days or longer. And you're going to see this on the next slide. It is important for me to note that this denitrification is not the opposite of nitrification. The terminology is confusing. It's most certainly confusing, but it is not the opposite of nitrification. Okay? I'll leave it at that. I would put an asterisk on this because you might be asked, is denitrification the opposite of nitrification? Yes or no? And I would hope you would say no. So denitrification most certainly occurs when soils are saturated or anaerobic for a prolonged period of time, longer than 5 days, 7 days. And so what affects denitrification? Denitrification is affected by the amount of oxygen present in soil. The microorganisms that cause denitrification are anaerobic microorganisms. These are organisms that do not need oxygen or need oxygen in very, very low concentrations in order to force denitrification to occur. So part of this is illustrated in this figure. So this is a figure that's extremely outdated, but I can tell you, because I've done this type of work over my career, that if we were to go out into a field in May or June of any given year and perform this same study, we would see the same exact results. Okay, so what you see is on the x-axis time, and what you see on both y-axis are oxygen content in the soil or the amount of N15 isotope labeled N2 gas on this far right y-axis. So this is what somebody did. They added nitrate nitrogen that was isotopically labeled with N15 to a soil at some point in time, and then either irrigated or had a natural heavy precipitation event occur that filled the pores almost completely, if not completely full of water. So what you see is the oxygen content in the soil drastically decreases at some point in time. And this soil likely stayed saturated from, I'm guessing, about May 20th to likely June 5th. It's a long time, 15 to 16 days. Then what you see is the oxygen content bounces back because the soil starts to drain. Finally, during that prolonged period of saturated conditions, we see the amount of N15 labeled gas coming off the field spiking because the soil is saturated for a prolonged period of time, and the microorganisms, the anaerobic microorganisms, are converting the N15 labeled nitrate to N2 labeled 15 labeled gas. Eventually, this decreases because the soil becomes oxygenated again. Now, it's a nice study, but the take-home message here is that this occurs all the time in our soils, especially soils that are saturated for prolonged periods of time. You don't need N15 labeled nitrate for this to occur. It happens with normal N14 nitrate in soils. It's a good take-home message. A couple other points about the anaerobic process. And in your notes, there are, I know, 2 bullet points under this topic. Cross the first one out. I don't want to focus on this because it just it has confused my students in the past. So I crossed that out. I think it's important for you to know that denitrification does occur in aerated soils, but to a much less effect, or it's less significant. So this cartoon illustrates this. And this is a good point for not only denitrification, but for all of the transformations that occur in soils, that they all occur at the same time at greater or lesser extents. So let's focus on denitrification here for a second. So imagine that this soil is well drained. All right, the larger pores have been drained of water, but there's still smaller pores or microsites that are filled with water, and they remain anaerobic for longer periods of time. And thus, denitrification will occur to over time in these little microsites. So that's important for this section of this unit. On a larger scale, I can tell you that denitrification occurs all the time to greater or lesser extents. So does nitrification, so does volatilization, so does mineralization, so does immobilization. All of these occur to greater or lesser extents. So sometimes you'll hear people say net denitrification or net mineralization or net nitrification. And what they mean by the term net is that they're accounting for all of the other changes or transformations that occur in the background behind the scenes as compared to that particular transformation itself. Okay. There is another factor that affects denitrification, and it's simply the amount of organic matter present in a soil. And that's because these anaerobic microorganisms need energy in the form of carbon to perform denitrification. It's a food source for them. Two other factors that affect denitrification. One is temperature, and denitrification is negligible at very low temperatures, say less than 36 degrees Fahrenheit, and denitrification increases with temperature. And it certainly overlaps the sweet spot or zone with respect to the, the transformations that aerobic organisms need with respect to temperature. They fall between 25 and 35 degrees Celsius, which is close to 75 degrees Fahrenheit. It's not surprising that they all sort of fall in the same location. The other factor that affects denitrification is pH. And generally, denitrification will increase as pH increases up to about pH 8, and then it tapers off. So if you know anything about denitrification and the factors that affect denitrification, you might be able to play with the system a little bit, at least keep it drained to prevent denitrification from occurring.